We're starting now chapter 2 of Pure Maths, and this chapter is all about functions and graphs. And as you're going to see, most of the functions that we're going to talk about in this chapter are quadratics. Now, what is a quadratic? You know this for a long time. A quadratic is a function that is in the form ax squared plus bx plus c, in which a, b, and c are constants, are numbers. So if you see any function that has this term over here, x squared, this means that you are looking at a quadratic. The first thing that we're going to see, and this is for lesson 1, is the factorization of quadratics, the use of the quadratic formula, and the completed square form. Okay, I don't know what happened, but this is back on. What do I mean with this? You are mostly going to use this for different purposes. The first two, the quadratic factorization and the quadratic formula, are going to be used for you to basically solve quadratic equations. The completed square form, as you're going to see, allows you to determine one very specific point in a quadratic that is going to be vital for you to be able to sketch it. Okay, so let's start first with quadratic factorization. So a quadratic is anything that has these three terms. As you're going to see, these three can be reduced back to 1. What happens if the coefficient of x squared is 0? That's why I have this in brackets. If this is 0, then you are left with bx plus c, and this is the equation of a straight line, right? So this means that you are back to a straight line, not a quadratic. So we'll literally take this out of the equation. Okay, so let's put a as being a constant that is not 0. And the first situation is, what if a is 1? So here you just have x squared. Then it may happen that b, the coefficient of x, is 0, in which case you either have x squared plus c or x squared minus c. If you have x squared minus c, I'm going to start with this one. You can always factorize this, putting things in this way, all right? I'm going to show you the example, and it's going to be much more, much simpler for you to see what I want to say. So say that c is 9, okay? So you have x squared minus 9. You can easily factorize this into x minus 3, x plus 3, right? You know this for a long time. If you cross multiply, you are back over here. More specifically, if you have minus 3 times x, that's minus 3x. And then you have x times 3, which is plus 3x, and these two cancel each other out. And you are left with these two terms only, okay? Even if this number is not a square number, and it is in this case, you can always write whatever you have here as its square root, okay? If this was 3, you could write this as x minus square root of 3, x plus square root of 3, and that would be it. You would have this factorized. Now, if this is a plus, there's nothing you can do, okay? You cannot factorize that. What if b is not, no, if, let me see again, okay. Now, b is not 0, but c is 0. Then you are left with these two terms. You'll have x squared plus bx, b being whatever. This is very simple to factorize. Just factorize x, and this is what you'll have, right? For example, if you have x squared minus 7x, this is the same as having x times, open brackets, x minus 7, and that's it. What if both b and c are not 0? What can you do? Well, in that case, you'll have an equation like this, x squared plus bx plus c, okay? And this is very simple to factorize as well, all right? As long as the quadratic is factorizable, if this word exists. And what you have to do, okay? You will, to factorize this, eventually, you'll have this expressed as a product of two things, in which alpha and beta over here, they are going to be numbers. And how do you figure out what these numbers are going to be? You have to look at b and c. And you have to mentally do a very simple calculation. You have to figure out what number is it that is going to be the outcome that added together, is going to yield this coefficient b. And what two numbers, the same numbers, multiplied together will yield this value over here, c. Okay, so again, you have to think of two numbers that added together gives you this, and multiplied together gives you that. I must warn you that this doesn't happen always. In other words, it's not possible to you to figure out this in every single situation, but most of them you will from my experience. Example, let's say that you have this quadratic, x squared minus 2x minus 24. Think of two numbers that added together yields minus 2 and multiplied together yields minus 24. These are the numbers minus 6 and 4. Minus 6 plus 4 is minus 2. Minus 6 times 4 is minus 24. So these are the numbers that go over here. This is the value alpha, and this one is the value beta. Okay? If you have no practice of this from previous years, and chances are that you already do, I guarantee that after you start solving or trying to factorize quadratics this way, this is going to become very easy. And you actually are going to look at quadratics and already look at these numbers, and eventually you'll know what these two values, alpha and beta, are going to be. It's just a matter of practicing with enough exercises. What if a is not 1? In other words, what if you have a coefficient that is not 1 here on the term with x squared? Then my advice to you is still try to do something like this. I didn't write it down in these notes because this is too complicated to write as notes, but pay attention to the exercises that come after, particularly the lower tiers, not the exam exercises, but the ones that are in the Access Pro, and you will see a way to factorize expressions of this type that are somewhat similar to this. It involves some extra steps at the beginning, but eventually you'll come into something like this, and with practice you can reach it very quickly. But if you don't bother to know that, or to memorize, or to understand how that works, you can always recur to the quadratic formula. Okay, the quadratic formula, you know this for a long time. All right, you have it here. So x equals minus b plus or minus square root of b squared minus 4ac over 2a. You have this on MF19, by the way. You don't need to memorize it, although chances are that you already know this by heart. And this formula allows you to solve every single quadratic. Okay, this is your Swiss Army knife of quadratics. You can always recur to the good old quadratic formula and be sure that you are going to find a solution to your equation. Basically, in this case, you have to set this up as an equation for you to get the two numbers with which you are going to factorize the quadratic. The only situation in which you will not be able to do this is if the outcome of what you have inside the square root is a negative number. But more on that in just 1 minute. Okay, so how does this work? You use a quadratic formula, equal this to 0, and solve it. Eventually, you are going to have two solutions, alpha and beta. If alpha and beta are the solutions to this equation after you equal it to 0, then the quadratic can be factorized into x minus alpha and x times x minus beta. Okay? If you find those two solutions, then this is it. You have the equation factorized. For example, let's say that you have this quadratic. If you solve it by substituting the corresponding coefficients in a formula, you will get these two values, x equals minus 1/3 or x equals 1. So you will be able to rewrite this as x minus that one times x minus this one. So a double negative becomes positive. Okay? All right. What about the completed square form? This is not a factorization. This is a way of representing the quadratic from this way into something like this. Okay? In which D, E, and F are also numbers. Okay? So how do you come to get these numbers over here? I bother to put this over here, but this is not for you to memorize. All right? It's for you to, if you're not afraid of looking at the letters instead of numbers, this will make more sense to you. But probably you are going to know how to do this using the example that I have here on the right. And I guarantee that with enough practice, you can go from here to here in less than 5 seconds. Okay? Let me try to explain the process using letters, but keep in mind that these letters in a real situation are going to be numbers. So this is going to be actually much simpler than what it looks, okay? Much easier done than said. Just practice with a few actual situations, and I'm going to make the parallel of what I'm doing over here with a real example, okay? So let's start with a quadratic written in this way. In this case, it was 2x squared plus 4x plus 6. What is your first step? Factorize the a. Whatever the coefficient of x squared is, factorize it. If this is 1, better yet, you don't have to worry about this step. You go straight into what's happening over here. But if the coefficient of x squared is not 1, you need to factorize it to begin with. Okay? So factorize a. So whatever b and c is now need to be b over a and c over a. Okay? In this case, if I factorize 2, what do I have here? I have 2 because 2 is 4 divided by 2. Your b is 4, your a is 2, so 4 divided by 2 is 2. Here your c is 6, your a is 2, so c divided by 6 divided by 2 is 3. See how these numbers, how these letters actually correspond to numbers in the real situation? Okay. Now, what is the part that actually relates to the completing the square? You will always do this. Once you reach this phase, you will always do this. Focus on what you have inside the brackets, and then just open brackets, write x, and write whatever this number is divided by 2. Close brackets and square. I'll say again. Open brackets, write x, then plus or minus, depending on what you have over here. And then whatever that number is divided by 2, close brackets and square. Look at what I did over here. I just put these square brackets because I'm working with what I have inside of here. And since I will have to use another brackets, which are going to be these over here, to differentiate one from the others, I just put the ones that are outside as square brackets. Having said that, what do? I open brackets, I write x, I look at the sign, it's a plus, I write plus, I look at this number, I half it, half of 2 is 1, write it down, close brackets, and square. Okay? So I already have this bit. Now think of what I've just done. I've created here a square of a sum, right? If I try to expand this, what will I get? I will have x squared plus 2x plus 1, isn't it? The first two terms is what I had over there. So x squared plus 2x is what I have over here. What I don't have is the plus 1 that comes after expanding these brackets. And I don't want that because I don't have it there. So what do I have to do? I have to remove it. Okay? So what is the next step after you close these brackets and you put the square? You look again at what this number is. You square it and remove it by subtracting it. Okay? So again, I look at what that number over here, this number over here is. I square it and I remove it. Okay? And what is the last step? The last step is just writing whatever you have there. Plus 3, I write there, plus 3. In this case, I write the c over a that I have there. I write it again over here. And I close brackets. And basically the completing square part is done. All I have to do now is to expand this brackets again. So I'll multiply a by this stuff. I'll multiply a by that stuff. Okay, let's write it over here. I'll multiply 2 by this stuff. I'll multiply 2 by that stuff. And that stuff is what? Is minus 1 plus 3. Okay, which multiplied by 2 is 4. Okay, so basically I end up with this and this. Compare. This d is going to be the coefficient of a, so this one is very easy to identify. This e over here is going to be whatever, it's going to be the outcome of doing this calculation, b over 2a, and this f over here is this. If you are good at memorizing, and I'm not, I'm horrible at memorizing, I would never be able to memorize these values over here, but if you are good, I invite you to just memorize this. Learn that C, B, and A, this should be, by the way, with a color scheme, this should be orange and this should be green. If you will just look at whatever the coefficients of x squared, x, and the number is on the quadratic as written this way, if you memorize those, if you look at those, and if you memorize these expressions, just substitute and you'll have the number, okay? But I guarantee that with enough practice, this method takes much less time than doing this, all right? So factorizing the a, putting everything else inside brackets, then doing the completed square form on the thing that you have inside, open brackets, x, whatever this ein is, and then whatever b is divided by 2, close bracket square, minus whatever this is squared, then you just add whatever you have there. If it is plus c over a, that's the plus c over a. If it was minus c over a, then it is minus c over a. Then do the calculations and expand the outermost brackets, and it's done. On the next lessons with the examples, with the exercises, you have a few of these examples solved. So I urge you to try first to solve them yourself. And then if you have any trouble understanding the solution, just go to my video lesson to understand how this can be done very simply. And this is going to be used throughout the rest of the chapter because this is a very important tool to get one thing called the vertex of the parabola. You can get it straight away from the completed square form, okay, from here. And you are going to see me doing this in less than 5 seconds in these exercises.